Okay, Algebra 2C, we're here working on the third page of the review for 7.5 to 81. This is problems 19 through 28. Okay, so now we're dealing with imaginary numbers. And just like the last page, what we need to do is we need to multiply both numerator and denominator by I over I. Now remember, in the numerator, I'm going to have to distribute this I. So now I have 2I plus 2I squared over 9I squared. Okay? And now we can simplify the I squareds. Remember, I can replace I squared with -1. And what that simplifies to is actually my final answer. I have 2I minus 2, because the I squared is replaced with -1, over a -9. And now the reason why we're done is because we do not have an I in the denominator. Same thing with number 20. I'm going to multiply by a form of 1, I over I. Make sure you got to distribute to both parts of the numerator. So I get 3I minus 9I squared over 8I squared. Replace the I squareds with -1. And now we have 3I plus 9, because remember it was -9I squared. Replace the I squared with -1 makes it positive over a -8. And that's our final answer. Okay, that was division. Now 21 through 28 we're going to factor, and we're going to solve by square roots. So we got to factor n squared plus 2n minus 3. So we need two numbers that multiply to -3 and add to 2. So we're going to do n plus 3 times n minus 1 equals 0. And now we got to set both parts equal to 0. So n plus 3 equals 0, and n minus 1 equals 0. That comes out to n equals -3, and n equals +1. Notice how we have our two solutions. The next one, I need to get the whole thing equal to 0. So I'm going to add 4r to both sides. So I get r squared plus 4r equals 0. And check out the GCF. The GCF for r squared and -4r is just r. So now we have r plus 4 equals 0. And set both parts. Don't forget about that r up front. So we have r equals 0 and r plus 4 equals 0. Subtract 4 from both sides. You get your second solution. We have 0 and -4. Okay, 23 and 24 are a little more difficult because this is when a is not 1. So what I'm going to do here is if I have 5n squared plus 16n minus 3, really quickly I did make a mistake here, so let's make it a +3. Okay, that's what's going to allow us to factor it. Okay, so I'm going to go to the next page and I'm going to do this on a separate sheet so we can show you all the steps. So if I have 5n squared plus 16n plus 3, remember I need to multiply a times c. So 8 times c gives me that 15, and I need to add to 16, which is my b value. So what two numbers multiply to 15 and add to 16? That's going to be +15 and +1. Okay, so I'm going to break that middle term off into +15n and +1n. And now I can group the first two terms together, group the last two terms together. Take out my GCF of 5n, and I'm left with n plus 3. There is no GCF between n and 3 besides just 1. So if I take out 1, I'm left with n plus 3. And we know we're doing it correctly because they have the same thing in parentheses. So now that they have the same thing in parentheses, I can write 5n plus 1 times n plus 3. And now we're factored. So now I'm going to use that in my problem. Okay? I'm going to go back to the problem. And now that it's in factor form, I
May
can
I have your attention, please? Mary Ellen Peterson, please dial the operator. Mary Ellen Peterson, please dial the operator.
So now I can set both products, 5n plus 1 and n plus 3, and I can set them each equal to 0. And now we'll get our two solutions. Subtract 1 gives me 5n equals -1, and divide by 5 gives me -1/5. Okay, subtract 3 gives me n equals -3. Those are my two solutions. Okay, for the next one. Before we jump over to factor, remember we need it equal to 0. So I'm going to add 11x to both sides. Now I have 3x squared plus 11x minus 4 equals 0. And now I'm going to check it out on a separate sheet of paper. Okay? So if I write this over here, I now have 3x squared plus 11x minus 4 equals 0. Multiply a times c, which gives me -12. And my b, which is 11. Two numbers that multiply to -12 and add to 11 are going to be +12x and -11x. So, or negative 1x, sorry. So now I'm going to break that off into those two terms, bring down my first term, bring down my last term, and now I can group. Group the first two terms together, take out the GCF of 3x, x plus 4 is what we're left with. For this one's key, group the second two terms together, got to pull out a negative 1, so I get an x plus 4 in parentheses. Now we know we're doing it correctly because we have x plus 4 here and x plus 4 here. And now we're left with our final factored form, 3x minus 1 times x plus 4. So now I can bring those two factors back to our original problem, and then we'll solve. So we factored it into 3x minus 1 times x plus 4 equals 0. Solve for x. Add 1 gives me 3x equals 1. Divide by 3 gives me x equals 1/3. The other one, subtract 4, it gives me x equals negative 4. Okay, so those are our two solutions. Last but not least, we have a little easier problems by taking the square roots of both sides. So if we're looking at 25, I need to isolate what's being squared. So in this case, it's the n squared. For 26, it's also the n squared. For 27, it's the whole v plus 2 squared. And for 28, probably the most challenging one, it's the whole x minus 1 squared. So I need to isolate that. For 25, I'm going to subtract 1 first. So I get 2n squared equals negative 4. Divide by 2, so I get n squared equals negative 2. And then I'm going to square root both sides because it's isolated. So if I square root both sides, I'm taking the square root of negative 2, which is my imaginary number, root 2. But remember, we need our plus or minus. So n equals plus or minus I root 2. For 26, same idea, add 2. So now I get 9 squared equals 9. Divide by 9, I get n squared equals 1. Square root both sides because it's isolated. N equals my plus or minus 1. Okay, so notice how they're getting pretty easy if you get the hang of it. Now for the next one, I need to isolate the v plus 2 quantity squared. So please don't multiply it out, isolate it. So I'm going to subtract 8. So now I get v plus 2 quantity squared equals 12. Square root both sides because now it's isolated, so I have v plus 2 on the left. I need to simplify my square root of 12. I can do that by doing root 4 times root 3, so I get 2 root 3. But remember, it's going to be plus or minus. So I have plus or minus 2 root 3 on the right. My last step, get v by itself, subtract 2. So I have the negative 2 that I just subtracted, plus or minus 2 root 3. And we can't combine them anymore because one's a root 3 and one is not. Okay? Last but not least, isolate, subtract 6. So I get 4 times x minus 1 quantity squared equals negative 28. Divide by 4, so I get x minus 1 quantity squared equals negative 7. Now it's isolated, I can square root both sides. And I get x minus 1 equals, can we simplify the square root of 7? I don't think we can, but we can take out the imaginary part. So it's I root 7. And remember, we always need our plus or minus. And now we just add 1 to get our final answer. X equals 1 plus or minus I root 7. And these cannot be combined anymore because one's a real number and one's an imaginary number. Okay, check those out. Notice how a lot of them, or actually all of them, have two solutions. Numbers 21 through 28 all have two solutions.